Hi everyone, in this video we are going to review these objectives. We are going to review past Regents questions related to subatomic particles, mass numbers, and charges. Bottom line is we are going to look at some questions and try to figure out the puzzles. So here we go. Number 1. The region that is the most probable location of an electron in an atom is... Well, we've got several locations in an atom. Most notably is the nucleus and the area that surrounds the nucleus known as the orbitals. So right then and there I do see two choices that do not make sense. Excited state that relates to electrons but has nothing to do with their primary location, and an ion which relates to an atom's charge. Okay, so as far as the location that we would find the electron, if we were traveling in an atom and wanted to capture one ourselves, well, relates to this picture. In the center here is our nucleus where we would find protons and neutrons, and this guy here, this one, and this one are electrons circling that nucleus, similar to planets in orbit. Now, there is an even better description of this. Let me get this out of the way and show you this guy here, which I did show you on our last video. And this, again, is the nucleus, and these are the electrons. And the electrons are actually in orbits, but these dots represent locations an electron might be found at any given moment. So each one of these dots is placed there as though you froze time, and the electron was frozen in this position right here, and then a moment later is frozen in this position, and it gives you this scattered drawing. But again, it kind of highlights an orbital. So, bringing back to the question at hand, the best answer here is an orbital. Now for number 2. The mass of a proton is approximately equal to the mass of an alpha particle. Now, we simply referred to an alpha particle when we talked about Rutherford and his gold foil experiment, and we said it has a positive 2 charge, suggesting that there would be 2 protons. 2 protons would definitely not be equal to the mass of 1 proton. Anyway, we'll get into alpha particles deeper when we talk about nuclear chemistry. So it is not alpha particle. Furthermore, it is not beta particle. Beta particle is very similar to an electron, but again, we'll talk about that more in nuclear chemistry. A positron, nuclear chemistry, but a positron is similar to an electron, but has the opposite charge, so it's like an electron with a positive charge. And our last standing answer is a neutron, and in fact, that is true. Both protons and neutrons have 1 atomic mass unit to them. Now, an atomic mass unit is just like, well, let's just say a gram. It's a unit so that we understand, well, what the mass is, so that when we compare it to something else, think of it to a dollar. You really have a great appreciation of what 25 cents means because your base unit in your head of a dollar makes sense to you. So to understand the mass of a neutron or a proton, an electron for that matter too, they devised a unit called atomic mass unit, so you have some basis of comparison. So again, a neutron and a proton both have 1 atomic mass unit each. Alright, number 3. Which statement compares the masses of 2 subatomic particles? So we're looking for a correct answer. So it's kind of like a true-false statement thing going on here. So the mass of an electron is greater than the mass of a proton. That is false. The mass of an electron is greater than the mass of a neutron. Well, the last question had me devising or letting you in on the fact that a proton and a neutron both have the same mass. So an electron greater than a neutron, again, false. The mass of a proton is greater than the mass of an electron. Now that is true, but let's examine number 4. The mass of a proton is greater than the mass of a neutron. Again, protons, so mass of a proton is equal to the mass of a neutron. So, well, that is false as well. The answer is 3. It is true. Number 4. Which statement matches a subatomic particle with its charge? Let me give you these symbols here and then you decide. Protons have a positive charge. Neutrons are neutral. And electrons have a negative charge. Number 1 says a neutron has a negative charge? No. 2, a proton has a negative charge? No. I'll skip to 4 now. A proton has no charge? No. Number 3, a neutron has no charge? Looky there. That's it. Nice. Number 5, which two particles have opposite charges? Well, let me make that, write down those symbols again for you. Proton positive, neutron neutral, electron negative. Hi, Tricia.
Hi.
Choice 1 says an electron and a neutron have opposite charges. Nope. An electron and a proton? I'll just stop it there. Absolutely. Proton has a positive 1 charge. Electron has a negative 1 charge. There she is. Number 6. What is the nuclear charge of an atom with a mass of 23 and an atomic number of 11? First thing I notice is it says nuclear charge. So what is in the nucleus? In the nucleus lies protons and neutrons. Are we talking about electrons? Absolutely not. Only the charge from the nucleus. So what can we pull from this? It says an atom with a mass of 23 and an atomic number of 11. Now, one thing we must know, vocabulary. Atomic number relates to the type of atom you have. For instance, carbon. Carbon is always 6. Hydrogen is always 1, and so forth. So atomic number tells you what element it has, but it also tells you the number of protons that you have. Now, seeing that protons are the only thing that have charge in that nucleus, and the atomic number is 11, the number of protons must be 11. So 11 protons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, each with a plus 1. You do have a plus 11 charge. Well, 11 plus, the answer is 1. Number 7. What is the total number of neutrons in an atom of an element that has a mass number of 19 and an atomic number of 9? Well, let me draw this out, the atomic symbol here for it. And let's say hypothetically the element is X, just so that we could get things rolling here. Atomic number is 9 and the mass is 19. Alright, now we do not have to focus on electrons whatsoever here, but we do need to know that this number is equal to the number of protons, and that this number here is the number of protons plus the number of neutrons. So, if we already know that we have 9 protons, we could put a 9 over the top of this. And we know that the total mass is 19. We could actually do 9 plus what equals 19. So what must go here? Well, 19 minus 9 is equal to 10. We must have 10 neutrons. Alright, so number 8, almost done. What is the mass number of an atom that has 6 protons, 6 electrons, and 8 neutrons? Well, let me draw this out for you, and then you tell me. Well, protons have 1 AMU, that's atomic mass unit. Neutrons are equivalent to 1 AMU, and electrons are equivalent to 0 AMU. There's really a tiny bit of a mass, but it's so small for our concerns, we ignore it. Alright, so give it a shot. I'll pause just for a moment. Alright, so how many protons? 6. So we multiply that by 6. So our mass just from the protons is 6 AMU. Electrons, well, that doesn't matter. No mass from them. And 8 neutrons times 8. So we have 8 AMU from the neutrons, giving us a total of 14 AMU. The answer is number 3. Not so happy that they didn't have the units built into the answers because it leads you astray. We always need units, especially when it's a fill in the blank or a constructive response question. Always put in your units. And last, an ion that consists of 7 protons, 6 neutrons, and 10 electrons has a net charge of what? First, consider your vocabulary. An ion means an atom that has a charge, either positive or negative. It is not neutral. Now let's consider the subatomic particles that it's talking about. It's talking about protons, neutrons, and electrons. We know that protons have a positive charge. We know that neutrons have a neutral charge and electrons have a negative charge. Now the proton's charge is, for every proton you have a positive 1. So we are going to multiply that by the number of protons we have, which is 7, resulting in a 7 plus charge from the protons. The electrons have a negative 1 charge, and there are 10 of them. So as a result, we have a 10 minus charge. Now for those of you that simply can look at this and realize that for every 1 electron we're canceling out 1 proton and we end up with 3 extra electrons, it is a 3 minus charge. But for the rest of us, let's map it out this way. In green I will mark every proton that we have as a positive charge. So we have 1, 2, 3, 4, 5, 6, 7. Now over top of that I will mark in red every electron with a negative charge to show that they cancel each other out. So here's 1, 2, 3, 4, 5, 6, 7. Now those have neutralized each other. As a result, we still have 3 more electrons. 1, 2, 3, each with a negative 1 charge, resulting in a 3 minus. Your answer for number 9 is choice 2. I hope this helped.